All right, class, let's look at section 4-3 today. And today we're going to look at this idea of multiplying monomials. Now there's that word monomial again. Remember, we saw, mono means one, so this means we've got single terms that we're multiplying together. So let's look up here at my first example. And again, our objective is to learn how to multiply a monomial by a monomial. And so if I look here, I've got x squared written right by x to the fifth. And we learn when these two guys are written right beside each other, we're just multiplying. Now, here's what I'm asking you to do. I'm asking you to expand those. So if I was to expand x squared, I would write x 2 times. And if I want you to expand x to the fifth, then you're going to write that x how many times? That's right, 5 times. So now we've got 1, 2, 3, 4, 5. So if I look there, now if I want you to put it back together, how many x's are there? That's right. This would give me x to the 7th. Okay? If you remember, this was my x squared that I put expanded. This was my x to the 5th that I expanded, and now I end up with x to the 7th. So we're going to see then, in order for me to write a rule of exponents for products of powers, if I have the same base, okay, if the base is the same, if you notice they're both a and a, then I can add my exponents. So if we have the same base, we can add our exponents. Now we're going to start doing some different things, and one of the questions I have you ask yourself is what is the same? And so we're looking for letters that are the same base. So let's go over here and practice a few together. Now remember, it's algebra class, so it's a number thing and a letter thing. So if I look at the first one up there, let's decide what we need to do. Well, we've got a monomial 5y cubed multiplied by a second monomial negative 2y to the 4th. Well, let's look at the number part first. If I look at the number part, what is 5 times negative 2? Yeah, everybody says what? Negative 10. And now, what is y cubed times y to the 4th? Well, they're both the same base. They're both y. So that means we're going to add the exponents, and we're going to get y to the 7th. Great job. Now, let's look at number 2. When I look at number 2, this time we're multiplying 3 monomials together. Well, again, I'm going to look at the number part first. Remember, there's an understood 1 in front of that first monomial, so we've got 1 times 5 times 3. Well, that's pretty easy. 1 times 5 times 3 is 15. Now, let's look at each letter separately. Let's look at the A's. I've got A. Remember, there's an understood 1 right there with that A squared and A cubed. So if we add all those together, we're going to get A to the 6th. And then we still have another letter. What's our other letter? B. We've got B, and we've got B squared and B cubed, and when I add 2 plus 3, B to the 5th. So my final answer when I multiply those monomials together is going to be 15, A to the 6th power, B to the 5th power. Let's look at our third example here. Once again, we're multiplying 3 monomials together. Oh, did you notice everybody has a minus sign or a negative sign? Again, I'm going to check out those signs first. Am I going to have a positive answer there, or am I going to have a negative answer? That's right, this is going to be a negative answer. There's an odd number of negative signs, so my answer is going to be negative. Now let's look at the numbers. Well, the only number visible there is a negative 3. Okay. Remember, there's understood 1s in front of the others, but that's still going to give me negative 3. And now let's look at the letters. We've got r squared times r. So r squared times r is r to the 3rd power. And then let's look at the next letter. That's an s. If I look at the s, we've got s times s cubed times s squared. And if we add all those exponents up, we're going to get s to the 6th power. So remember, when we're multiplying monomials, if I have the same base, I just add my exponents. Now, we've got 2 more to look at. So if we go over here, oh my goodness, number 4, Mrs. Burton threw in a fraction. Well, remember, I like to go ahead and put that whole number over 1, because if we can cross cancel, we can. But first thing we're going to do is we're going to go ahead and multiply the numerators. So if we multiply the numerators, what do we have? We have 2 times 21. Well, 2 times 21 is 42. And then we've got a squared, and a to the 5th is a to the 7th, all over, and we've got 7 times 1, which is 7. Oh, Mrs. Burton gave you a fraction. Can we reduce that fraction? Better check it out. We sure can. What's 42 divided by 7? 6a to the 7th is my final answer. Now, number 5, a little bit curious. Ooh, what do you think we should do first? That's right, order of operations says that I should actually multiply first. So let's multiply these 2 together. If I look at the numbers, we've got 2 times 4, which is 8, and then we've got y times y cubed. Remember, if they're the same base, they're both y, we add our exponents. 3 plus 1 is 4, plus, let's go over here and add these together, or multiply these together, I'm sorry. We've got 3 times 5 is 15, and we've got y squared times y squared, which is y to the 4th. Now let's look. Can we add those? Of course we can. Did you notice they're like terms? They are. Okay? Our variables and exponents are exactly the same. Remember, we learned yesterday like terms have the same letter and the same exponent. The only thing that's different is my coefficients, those numerical coefficients out in front. So we just do the math with the numbers. What's 8 plus 15? That's right. Everybody says what? 23, and then we've got y to the 4th. Remember, when we're adding, we're collecting like terms. So we only look at the numbers, the numerical coefficients that are out in front. All right, great job.